So today we're going to keep talking about our sequences. Like this whole entire chapter is pretty much like on sequences. So we've been focusing on the arithmetic sequences and pretty much like how do we add to get from one number to the next. We know that when it comes to our arithmetic sequences that we are adding the same number from one term to the next. So we know that it's linear. Right? We learned all those good little things yesterday. And so today we're going to work on finding our multipliers. So when we're working with the multipliers, what kind of sequence do you think that's going to be if you're multiplying? Starts with a G. Geometric. Yep. So then now we're going to sit there and focus today more on the geometric sequences and looking at those formulas. So in our little fancy textbook, this is like problem 93, and I just kind of screenshotted it and kind of squished it around, and then we can kind of read through it. So ultimately we have a pi phone is going to sweep the nation. Millions demand one. So teenagers and Hollywood celebrities flock to an exclusive shop in Beverly Hills, California yesterday to get a new Pi phone. Not an iPhone, but a Pi phone. The store expects to start by selling 100 and expects to sell an average of 15% more each week after that. So Nellie's going to stand in line all night because she thinks that she's going to be cooler than everyone else once she gets that phone. And just to let you know, phones do not make you cool, okay? All right. Oh, I just know. Years of experience. So they want us to go through and figure out, if we go through our little questions, given the article that they provided, how many Pi phones are the store expected to sell? We want to predict how many are going to be sold after the 4th week. And then we're actually going to figure out exactly, looking at that sequence, if we were right. Is it going to be arithmetic, geometric, or something else? The store needs to know how many phones to order for the last week of the year. If you knew that the number of Pi phones, so for 51, could you figure it out for 52? Write a recursive equation. Then we're going to write an explicit equation, right? And then we're going to actually figure out how many phones was our prediction for how many phones we needed, actually pretty close to the actual number that we need after that 52 weeks. Sound like a plan, Stans? Okay. So, let's try it now. How many Pi phones do you think the store will need? So how many Pi phones will the store predict to sell in the 52nd week? Give me some numbers. How many do you think? 400? Anybody else got anything? Number, any number. So they're selling 100 the first week. How many are they going to sell 52 weeks later if every week it increases by 15%? 600? Whoops, not erase. 600? Anybody got anything else? We good with those? So it's either 400 or 600, right? So, whoop, somebody say 1,000? You said 1,000? Anybody else got a prediction, or are we good with those 3 predictions? Pardon me? 52, yep.
Well, yeah, so 52 times 15%.
2,000?
3,000.
3,000?
Yeah. Are we like really low?
I don't know. I haven't done the problem yet. 23,000. Woo. Yeah. Anybody else got any other numbers? We good so far then?
Oh, Andrew said 5.
That's like 5 phones?
Yeah.
But they're already selling 100 in the first week.
Yep.
So how can they sell 5 if it's an increase?
Yep.
All right. So let's start by looking at a little bit of a table, right? And we know this has to be a sequence and not a function because it's going to be discrete, right? Because you can't buy half of a phone. So we're going to use our n and our t of n for a little notation, knowing that we're going to have a sequence. So when they started, before, like initially, they had how many phones? How many did they sell? 100. Right? So that was the first, Monday, Tuesday, Wednesday, Thursday, Friday. So then now we get up to 1 week. So we need to figure out how many phones they're going to sell in that next week. Okay? Say again. It would be just how many are they selling in week 1. Yep. So they're going to sell 15% more, right? So they're still going to sell the 100, plus they got to sell some more. How many more are they going to sell? Yep, and what's 15% of 100? 15, right? So in week 1, they're going to sell 115. So in week 2, right? Yep, they're going to sell that 115 plus another 15%, right? So we can start kind of thinking of this a little mathematically because we have our 115 and we want to somehow be able to combine that 100 and that 15% together, right? So like technically they're selling 115%, right? Because they're going to sell the original amount, which is 100%, and then they're going to sell another 15% on top of that, right? So in total, they're going to sell 115% each week. Could we write that as a decimal? Because if we're going to multiply, we can't multiply with our little percent sign. We have to turn that into a decimal. So what would that be as a decimal? Is that 1.15? So to figure out week 2, we would have our 115 times 1.15. Right? Because this would be our 100% and this is our 15%. So that's 115%. And what do we get when we multiply those together? $132. Yep. So then in the third week, we're going to have our 132, and they're going to sell 115% of those. And what are we going to get? $152. So you guys tell me, how many phones do they sell in the 4th week? $174. That works. Yep. So that answers our A question, right? Predict the number sold in the 4th week, right? And we figured it out to be 174. So on these ones, because our multiplier, what are we multiplying each time? Yeah. Yeah. So that common multiplier is that 1.15. Yeah. So since we're multiplying to get from one term to the next, we know that it is geometric. Yep. So just like when it came to the arithmetic, there was the explicit formula and the recursive formula to come up with the equations. So we can do the same thing for these ones. So if we want to come up with the explicit formula, and this would be for geometric, we know we have a sequence, so we have our T of n, and we're going to have A sub 0. What's A sub 0 stand for? That 0 term, right, or that initial value. Yep. And then we have C raised to the nth power. So this is our 0 term. Okay. Sometimes they'll refer this as the initial amount. So in our little phone problem, what was our initial amount that we started with? How many phones? 100. Yep. C, remember how before we called it the common difference because we were adding or subtracting? So this is just the common multiplier. Or they'll call it like the common ratio, right? What you're multiplying by. And n is the term that you're looking for, or that you know. Right? So when we look at our pi phone problem, let's see if we can come up with a equation or a formula. So we know we got a sequence, so we got T of n. So our initial amount, or that 0 term, right, we said was 100 because we started with 100 phones. And then in parentheses, I'm going to put my common multiplier. So what was the common multiplier that we went through and multiplied by? Yep, 1.15. 1.15. And we're going to raise that to the nth, right? Depending on what n we want to look at. So their question at the very end was to figure out how many phones they sold after 52 weeks, right? In the 52nd week. So what's our n going to be? 52 equals 100 times 1.15 raised to the 52nd, right? Think our prediction was close? Yeah. What do you get when you put it into your fancy dancy little calculator? $143,300 and I'm going to round up to 14 phones. Well, technically you can't round it up because you didn't sell it. So let me rephrase that, right? So, pi phones. Yeah. So in the last week of the year, Pi is going to sell 143,313 Pi phones. Crazy, crazy. All right, so I want to take a minute and go back to our little formula, and we're going to talk about this common multiplier for a second. So when you're looking at that common multiplier and we're talking about growth or decay factors, on our Pi phone that we were just talking about, they said that they had an increase of 15%, right? So when I'm trying to figure out that multiplier, if I'm increasing by 15%, like we were just talking about, you're still selling 100% of the phones, but you're increasing it. So you're increasing it by another 15%, right? And that got us 115%. And then we know that when it comes to adding, multiplying by percentages, we just have to turn that into a decimal, right? So as a decimal, that would have been 1.15. Right? But what happens if, let's say, pick on Android, right? But let's say that there was a decrease. A decrease of what percent? You pick the percent. Anybody got a percentage in mind? 20. I like 20. So let's say we want to decrease by 20%. So if we're decreasing by 20%, we were hoping to sell 100% of the product, but we're not selling 100% of the product. Our product is being decreased. So we're going to have to subtract 20%. And then that's going to give us what? 80%? And then if we write that as a decimal, we're going to get 0.8. Okay. So if I just threw some growth factors out at you, or if I just threw some factors out, let's go with some factors. So let's say I give you a problem and I tell you that the growth factor equaled 1.25. Is that going to be a growth or a decay? Is your number going to get bigger or is it going to get smaller? It's going to get bigger, right? What's it increasing by? What percentage? It's increasing by 25%. Yep. So that is truly a growth. If they gave you a growth factor, let's say it was 0.75, that's a decay. Well, it's a decay by what percentage? Is it a decay of 75% or a decay of 25%? Because remember, you wanted to sell 100, but you're not selling 100 of it. You're selling 75 of it. So it's a decrease of 25%. So when we get our little equations and we're looking at equations, we can, depending on what information they give us, if they give us what the factor is, if it's greater than 1, we know it's a growth. If it's less than 1, we know it's a decay. If they tell us it's an increase, we know we got to add it to the 100%. And if it's a decrease, we have to subtract it from 100%. Not too bad. Let's see if you guys can figure out a little factor from a table. Oops, gotta have ink. So I'm just gonna write mine horizontally. I'm gonna say we got, our 0, 1, 2, 3, 4. Our 0 is 3. Our first would be 4.5. 6.75, 10.125, 15.1875. I had to make it all crazy for you guys. Okay. So we need to figure out if this is arithmetic or geometric. Do you think you're adding to get from one term to the next? No. We're multiplying, right? So I got to multiply 3 by something to get 4.5. And I got to multiply 4.5 by something to get 6.75, right? And it's got to be that same multiplier for all of those. So I'm like, how am I going to figure that out? So let's see if we can kind of come up with a little equation. Because we know whatever our previous term is, we got to multiply it by something to make it equal this. Okay? So you can pick any term in the sequence, any two that are next to each other. So do we want to do 3 and 4.5? Or you want to do like 4.5 and 6.75? Sweet. We'll do these two, right? Just to make it interesting, right? So I know if I take my previous term, I have to multiply it by something, and it has to equal 6.75. Okay? So now that I have my equation up here, what would I do to get x all by itself? Divide by 4.5, right? Yep. 4.5 over 4.5 is 1, so that's going to go away. So what's 6.75 divided by 4.5? $1.5, right? So you just told me that if I took 4.5 and I multiply it by 1.5, I get 6.75. Right? If I multiply 3 by 1.5, what do you think I'm going to get? 4.5, right? So that's how you figure out those common multipliers, right? If it's something, I mean, if it went, 2, 4, 8, 16, yeah, you're looking at it and you know you're multiplying by 2, right? But when you get into like the decimals, it's kind of hard to figure out what it is you're multiplying to get from one to the next. So you can always set up a little equation and figure it out. Yes? And then, just for poops and giggles, I bet you we could come up with our equation. We know it's a sequence, right? What are we going to get? What's our, remember the formula? A sub 0 times that common multiplier raised to the n, right? So our A0 is 3. Yep. Our C we found out to be 1.5, and we're going to raise that to the n. And then now we could figure out a whole slew of the problems that are, or the values that are in the sequence, right? All right. You guys ready to try a couple problems? Let's see what we got going on. So problem 99, they give you a table and you have to find that common multiplier and come up with the equation, which is just what we just did on this one. 100, they want you to convert the percentage into an increase or decrease depending on what they're asking. So that was kind of like these problems, right? We're talking about the increases or decreases. We have one where you're just going to simplify some expressions. You got somewhere you're looking at a graph. Which graph looks like a sequence? Find the next 5 terms in a sequence, and then the last problem is solving each equation. Sound like a plan? Nice, easy Friday?